Welcome to Calculus Live. I'm your host, June Harmon. Call in and we'll work calculus problems together. Let's meet my student assistant for today.
Hi, I'm Martha Bruman. I am in Ms. Brzezinski's calculus class in Molina High School, and I plan to attend Baylor University.
My alma mater, excellent choice. Martha, why don't you remind the students about the rules?
Avoid feedback by using the telephone in the classroom. Cell phones do not work. Turn down the set a little when you're on the air and sit back and relax.
We are counting down until the AP Calculus exam on May the 3rd. Martha, how many days do we have to prepare?
There are 76 days.
Who's our first caller?
Our first caller is Erica from Molina High School.
Hey, Erica. Are you there? Erica? Molina High School? Who's our next caller? Is it a mystery caller?
It is a mystery caller.
It's a mystery caller. Who's our next caller? Hi, who's out there?
Hello?
Hi, who's out there? Who is this?
I said Ivany Diaz from Sunset.
You're Ivany?
Ivany, not Ivan.
Say it one more time.
Ivany.
Ivany. Thank you. We're going to find your picture. Do you know what number you are?
Number 5.
Number 5. Thank you so much. Hi, Ivany. We got you right here.
Yes, ma'am.
Excellent. Thank you for calling in. So how's everybody at Sunset today?
Oh, we're doing good. We're doing good. It's a little warm, but we're doing good.
It is a little warm. Just wait till tomorrow, right?
Yes.
Yeah, that's all you got to do is wait till tomorrow. All right, you ready for the first problem?
Okay.
Okay, Ivany, here's a problem for you. The function f, I put a g, but that was wrong, is continuous over the closed interval, -3 to 2, and differentiable over the open interval, negative. That's standard, isn't it? We say that a lot. Continuous over the closed interval and differentiable over the open. Are you still with me?
Yes.
Okay. I've got 2 points on the graph.
Okay.
-3, 5, and 2, -5. And I want to talk about which of these could be false, or you could say which of these are absolutely true.
Okay.
All right? So what would you like to do first, Ivany, to think about this problem?
Ew, I'm not sure.
Well, you know what I would do? I would graph
we're losing him.
and see what it looks like.
Okay.
You want to do that?
Yes, yes, yes.
Yeah, because you know when I'm not sure, I'm going to take something I know and I'm going to try to see what it looks like. So -3 up here at 5.
Okay.
-3, 5, and this one is 2, -5. Okay?
Okay.
So you can see I've got ordered pairs from up here. Now what did we say the function was? Continuous
Yes, it was
and
continuous.
differentiable, right?
Yes.
So that just means smooth and easy going. You don't really know anymore, do you, Ivany?
No.
No. So let's see. Do you think the y value somewhere is going to be 0? Is it going to cross the axis?
Sure, yes.
It absolutely is, so that's a yes.
That's right.
Do you think the value of the function is somewhere going to be -2?
Yes.
Of course. Because
Yeah,
it goes from 5 to
baby.
-5. That's your intermediate value theorem. Do you think the derivative is going to be 0 somewhere?
Yeah.
Does it have to
Yeah,
be 0
baby.
somewhere?
Yeah.
Could it just go like this?
Yes.
So that's the one, isn't it?
Oh.
You're not guaranteed a 0. When are you guaranteed a 0 derivative? When the function starts and stops at the same y value, right?
Right.
But this is mean value theorem. Do you think there's a slope of -2 somewhere?
Yeah.
Yeah, there sure is,
Yeah.
because that's what you get when you take the secant line. Okay?
Okay.
I like this question, Martha. It was on a test a few years back, and what I liked was it's really doable if you draw the graph. But if you just read, you probably will think, they didn't say take a derivative, did they?
No.
But if you draw a picture, go ahead and draw what you can, then I think you can figure out the answer. What do you
Hey!
think?
Oh, yeah.
That was easy.
Okay.
Okay.
Hey, thank you for calling in. You guys call back.
Okay, thank you.
Bye-bye. Who's our next caller, Martha?
Brittany from Skyline.
Hey, Martha.
Hi.
And who's your teacher?
Miss Johnson?
Miss Johnson. Thank you very much. I'm glad you called in today.
Uh-huh.
Do we have your picture?
No.
Oh, okay, well, that's all right. We're glad you called in anyway. Have you done E's and that sort of thing?
Yes.
Oh, okay, here we go. Oh, I want you to see my sign first. Do you see my sign?
Mm-hmm.
Math multiplies your options. Do you believe that?
I don't know.
Absolutely, we believe that, don't we? All right, here we go. I'm going to let you have a choice. Would you rather work this integration or this? Uh-oh, I'm sorry. I must have hit something. Let me try again. All right, I think it's calmed down now. You ready? Would you rather work this problem or this one? What do you think?
The first one.
The first one? Okay. Let me put something to cover up that other one. It does look kind of bad, doesn't it? Okay, here we go. You've got e to the 4x minus 3 cos of x dx. And we need to integrate. What are you going to do?
Well, first we're going to separate it so it'll be 2 integration
I
problems.
like that. Can you speak a little bit louder for me?
Yes.
All right, thanks, son. And you want to separate. Am I doing what you want me to do? Okay, good. I tried to write a little bit so you could see. All right, now tell me what you do. And different classes do it different ways. So what do you do with one like this?
I use U substitution.
You use U substitution. Tell me what you're going to use.
I'm going to use U substitution for 4x.
Good job.
Oh.
What does that make? What does that give you?
Your du,
du is
4dx.
4dx. And then what do you do?
Then I'm going to rewrite it.
Okay.
The first one.
Tell me what to write.
The integration of e to the u du. But since you have a constant as your du, you have to rewrite it. So you want to divide it by 1. You want to multiply it by 1/4 on the,
That's exactly right. You said that beautifully. Du over 4 is dx. So du over 4, but you like to pull it out front. Perfect. You want to finish this side before we go to the other one?
Yes.
All right. Tell me what to write.
And then you do 1/4 times e to the u, which will be 4x.
Okay, I'll go ahead and put 4x. Excellent. Don't you love integrating e to the u? It is so easy, isn't it?
Yes.
Okay, we did
Excellent.
fix. Now, you had to fix it to make it easy. That's perfect. All right, now shall we go to part 2?
Okay, first you want to bring out the 3 because it's a constant.
All right, -3, and I'll go ahead and rewrite so you can see it. Okay, and now what's that?
Then you want to integrate cosine x.
And what is the integral of cosine?
Sine x
And one more thing.
plus c.
Ah, perfect. You did a great job. You had
problemo.
You took you've integrated. Your room is applauding, and we're going to applaud and give you the bells. That was great. Listen, thank you for calling. You guys call back, okay? All right, bye-bye.
Bye.
Martha, who's our next caller?
Our next caller is Michael from SOC.
Hey, how's everybody?
Yes,
You doing well?
yes,
Good, good. I'm glad you guys called in today.
okay.
Let me find, I have a problem here that I think you're going to love. What have y'all been studying?
Fundamental field,
Say it again.
fundamental field.
Oh, okay. That's good. That's a good thing to be studying. All right, let's see. Y'all done E's already, haven't you? Have you integrated E or not?
Yes,
Okay, good. Some schools do it one time and some another. All right, let's see about this one. You want to look at this problem?
yes,
You think that one will be okay? All right, tell me what to write.
you can do U substitution.
Okay, tell me what to put.
U equals, is that -5x?
That's correct, -5x. It's hard to see those powers sometimes. What else do you do then?
Then you take the derivative.
What does that give you?
du equals -5 dx.
Perfect.
Correct, boy wonder.
And dx equals du over -5.
You do it just like I do it.
Oh.
Excellent.
Then you rewrite.
All right, tell me what to write.
Oh, before that, you change your limits.
Oh, I like that. Tell me what to change.
Change the bottom limit to 0.
All right, 0 goes to 0, and what does the top go to?
It goes to -5.
That is perfect, and you don't want to change them without something else, right? We're not going to just mess with them. All right, keep going.
E to U.
We're losing him.
And
du over -5.
I'm going to have to move over, okay? All right, now, Do you want to do anything about this negative 5?
You move it out in front.
All right, it's
you.
negative 1/5
Yeah.
integral. I'm just going to rewrite this so you can see
Wow.
it, okay?
Mm-hmm.
Get it where you can see it. All right. Anything else you want to change about it? Are you ready to integrate? What do you think?
Yeah, keep going English.
Okay, let's go. Integrate.
Negative 5. E to the 4.
E to the U, right?
Mm-hmm.
That's easy. With plug-ins. True?
Yes.
And now what do you plug in first?
You plug in negative 5.
Excellent. It's on the top, so it gets plugged in first. E to the negative 5. Take away 1/5. Take away negative, right?
That's right.
E to the what?
0.
Good. Did I get it right?
Yes.
All right. Did I
Hold
leave
on.
off a minus sign here? I'm sorry. I think I left your minus.
Mm-hmm.
Okay, good.
You can change the, both of them to, you can change to positive.
I could. And what is e to the 0?
1.
So I could write 1/5 times 1. I could leave this one. I'm probably going to leave it like it is.
Anyone?
What do you think?
Anyone?
I could bring
Yeah.
that e downstairs, couldn't I?
Yes.
Hey, you did a good job. Here's what I really like. You knew to change your limits. Sometimes they'll ask you to do that and leave the problem alone. And if you don't know to change them, then you miss those. So you did a great job.
Thank you.
Listen, thank you guys for calling in. You guys call back.
Okay.
Bye-bye. Who's our next caller, Martha?
Our next caller is Jarrell from Sauk.
How are you today?
All right.
All right, good. It's good to hear from you guys. How's your geometry?
It's all right.
Is it all right?
Yeah.
You know how to find the area of a semicircle?
Yeah.
Yeah, they expect you to know that. Now, they won't ask you to find the area of a cone or, they'll tell you some of that, the volume of a cone. But some areas they expect you to find. Let me show you this one. I got a problem I like here. Do you know how to find the average value of a function?
Yes.
Okay. You take tell me in words, how do you find the average value of this function?
No problemo.
You find the area under the curve.
That's right, the area under the curve, and divide it by what?
That's right.
That's right, the base. You find the area under the curve and divide by the base. So we know we're going to go 1 over 3 minus negative 3. That's a 6. Now, here's what I'd like for you to do. I don't want you to use calculus. I want you to find the area under the curve using geometry. And let me help you see what it is, because it's kind of hard to tell on TV. This is a semicircle, radius 3, and this is a box that goes from 3 to negative 3 and is 2 high. So what is the area of the box if it's 6 across and 2 up?
12.
That's right, that's just a 12. Plus, what's the area of a semicircle if the radius is 3?
3 your 3 pi.
Say it again.
3 pi squared.
It's pi, 3 squared,
That's right.
And it's only half the circle, so what do you need to divide by?
2.
2. Good job. So actually I've got 1/6, 12, and that's 9 over 2 pi. Now,
answer.
you could do more to it if you wanted to, but that's a good answer. You've got the base is 6, and the area is just semicircle and a box, right?
Yeah.
You could do that, and you don't have to use calculus. In fact, we probably don't know how to do this with calculus yet, do we?
No, no,
Not today. Maybe tomorrow, okay? Hey, thank you for calling in. Y'all call back. I'm glad you're listening. Martha, who's our next caller?
Our next caller is John from Bryan Adams.
Hey, John. Good. I'm glad you called in. You ready to do, how about a U sub problem where you don't actually work it out?
Okay, sure.
Okay? Without integrating, using the substitution u is 5x minus 1, write the equivalent expression.
Oh,
If u
righty
is
then.
5x minus 1, then what else? I'll go ahead and start that much for you. How's that?
Okay, yeah.
How do I find my substitution here?
The du,
That's right. Let's take a derivative. What is the derivative of this thing?
5.
5 dx. I've got dx, so I need to divide by what?
5.
That's right, over 5. And I can pull that out front. Now here's the critical piece. Most people get this right. But what do I have to do about these limits? I plug 0 in here, and what do I get?
-1.
Good. I plug 2 in, and what do I get?
9.
9. And they would probably write the 1/5 out front, -1 to 9, u cubed du. And the problem may say, set it all up, but don't actually work it out. And they're looking to see, and you know choice A is where they don't change these, right? For people who don't realize they have to change the limits to match. Is that okay?
Yeah.
That one's in your pocket, isn't it?
Yeah.
Thank you for calling in. You guys call back.
All right.
Bye-bye.
Bye.
Who's our next caller, Martha?
Our next caller is Nigel from Science and Engineering.
Hey, Nigel.
Hi.
Hi, who's your teacher?
Huh? I'm
Who's
sorry.
your teacher?
My teacher's Mr. Sanford.
Mr. Sanford?
Yes.
Excellent. So you're a BC student, aren't you?
Yes.
Uh-huh. That's good. You guys ready to make all 5s?
Of course.
Well, of course you are. Here's a problem for you. Now,
Hello,
you know, this
everybody.
show we do A-B problems, so this is like a little review for you. Okay, here we go, Nigel. Are y'all still excited about the president coming to visit?
Yes, that was cool.
It was cool, wasn't it? I liked all the good press. Y'all paid a lot of attention to the district.
Yeah.
All right, f of x is continuous and differentiable. Okay, fine, right?
Right.
On the interval 0 to 1. G of x is f of 3x.
Right.
Okay. This table gives values for f prime.
Okay.
Find the value of g prime of 0.1.
Okay.
All right, what do you think we should start with?
I think we should start by finding the derivative of g of x.
I like that idea.
Yes.
So g prime of x, well, tell me what to write.
G prime of x, you have to chain rule the f of 3 of x.
That's right.
You have f prime of 3 of x, and then you have to take the derivative of the inside. So
Good answer.
multiply by 3.
That is perfect. Now let's take that a step at a time for everybody watching. You took the derivative of the g function because you're looking for derivatives. So now, what are you going to do next?
Next, you are going to find... Oh, no, you plug in the 0.1 for
All right, let me plug that in for you.
Thank you.
F prime, now you tell me what to plug in here.
F prime of 3 times 0.1
Okay, so how about 0.3?
is 0.
And then times that big 3 that's waiting on us.
Right.
We're close. Now what do you do?
So then you have... So you find the value for f prime of 0.3 on the table.
Yeah, that's why they gave that chart. Now see, some people might have found this one by mistake, but it's this one, isn't it?
Yes, it is.
And what's it's 1.096
Yes.
times
3.
3. And how's your arithmetic?
It's good. Let me see. 3.282.
3.2.
82. For 8.
3.288. Look good to you?
Yes,
My
that's
arithmetic
good.
is sometimes better than others, okay?
Oh,
Hey, you did
oh.
a great job. Listen, thank you for that. You know, it looks kind of scary, lots of words, but when you focus on, I need a derivative, and that's what I need to take the derivative of. You did the perfect chain rule. You took the derivative of the f function, keep the 3x, don't mess with it, and then chain out the 3.
Thank you.
Thank you
That's
so
very
much for
inspiring.
calling in. You
Thank
guys call back. Martha, have we got anything coming up, some news that we need to talk about?
Yeah, we have a big prep session Saturday, February 25th at Townview from 9 to 2:30.
9 to 2:30, Townview, February 25th. I call it Christmas in February. What do you think? Come work calculus problems all day long. Martha thinks that's the most fun thing, right?
Yes, I do.
It absolutely is. Who's our next caller, Martha?
Our next caller is Nyla from Carter.
Hey, Nyla. Do we have Nyla from Carter? Oh, we missed Nyla. Well, do we have another caller?
Erica from Molina.
All right. Nyla, call back if you can. Erica, what's your picture number?
32, I believe.
32. We're going to find you. What'd you guys study today? Did you take a test?
Yes, we did.
Did you make a good grade on it?
I believe I did.
Excellent. Let me show your picture.
No.
Oh, sure. There we go. All right, Erica, let's see. Let's find you a really good problem. Erica, this is a problem that's not that bad if you know what to look for, and I bet you do. I'll give you a choice of this one or this
Wow,
one.
that's
Okay?
pretty heavy.
Let's read the problem first, and you can decide.
The first one.
You want? You want the first?
Yeah.
You don't love trig?
No.
Oh, okay. Well, all right. All right. Find the absolute maximum and minimum values of the function on the closed interval. and state where those occur. You got it? Now, there's some things we need to think about, right?
Yes.
Okay. We need to think about if we're finding absolute max and min on a closed interval, we've got some endpoints, right?
Yeah.
And we know we're going to check those. What else are you going to look for?
For the derivative?
Yeah, that's exactly right. So shall we take we know right now we're going to find f of 0, and we're going to find f of 1, and we're going to find f of anything critical in between. So what's the derivative, please?
8x minus 4.
Good job. And you're going to set the derivative equal to what?
0.
Excellent. And then what are you going to do?
Move the 4 to the other side.
Okay, and then what?
Divide by by 8.
That's right. 4 over 8 is also known as
1 half?
Is that in the interval?
Yes.
Yes, it is. So we are going to need to check f of 1 half. Now, on the free response, if you don't address all of them, even if you get lucky and find the right answer, you have to address all of them and say, I checked this, and this was this number and this number, and then you get all the full credit. All right, so now we need to evaluate. Now, Martha, where am I going to plug these in?
Martha?
I'm sorry, Martha's over here. Erica, excuse me. Erica, where am I going to plug these in?
To the function.
That's right. Some people forget and plug it in that other one that I'm not even going to name.
I won't forget.
All right, I know you won't. If I plug in 0, what do I get?
1.
If I plug in, let's skip down and do 1, okay? If I plug in 1, what do I get?
1.
Oh, those match. And if I plug in a half, shall we plug that in together?
Yes.
4 times a half squared minus 4 times a half plus 1. Can you clean that up and tell me what you get? Need me to write some over here?
Yes. 2.
4 times a fourth.
Yes. It's 4 over 4.
Okay.
1.
1. And minus 4 times a half is
2.
2 minus 2, and then plus 1 again. That turns out to be a big
0.
0, big nothing. So now tell me, which is the absolute maximum value and which is the absolute minimum value? And you'd want to write a sentence on free response.
The absolute max is 1, and the absolute min is 0.
Very good. It's the y values. And the absolute max occurs where?
At 1 and 0.
At 1 and 0, 2 places, and the absolute min occurs at
1 half.
1 half. Sometimes students answer the wrong thing. They'll say, what's the absolute minimum value? And students will answer 1 half when they meant 0, right? They'll tell where it happened. You did a great job. You knew exactly what to do. You knew to check those endpoints and critical numbers. Nothing else is in the game, right? Nothing else is a possibility.
Right.
Just the critical number and the endpoints. Listen, thank you for calling. You guys call back. Bye-bye. I should call you Erica to make up for that, shouldn't I? Martha, who's our next caller?
Mike from SOC.
Hey, Mike.
Hello.
How's Miss May today?
She's right here.
She doing well?
Yes.
Good. Did she make you work hard today?
Yes.
Well, of course. That's her job, isn't it?
Yes.
I got a problem for you.
Okay.
You like trig?
Not really.
Oh! Well, you're going to love trig before this is all over with, aren't you? Here we go.
Yes.
See,
Hello, everybody.
I used a word here to make sure that the audience, everybody knows what that means. Do you know what an antiderivative is?
Integrate.
Oh, good. See, that didn't bother you at all. Cosine of 3x dx. But we like to make sure that everybody knows, if it says integrate, if it says take an antiderivative, we do the same thing. All right, tell me what to do.
Use substitution.
Tell me what to write. That's exactly it.
That's right.
3x.
Very good. What's du?
3 dx.
Uh-oh, I don't have it, so how do you write it? Tell me what you do. Do you write du over 3, or do you do it some other way?
Du over 3.
Okay, good. Sometimes people do it a little differently, and I don't want to ever mess anybody up. Okay, tell me what to write now. Integral, cosine of
U.
u with du over,
2.
where do you put that over 3?
On the outside.
Yeah, I like to move it out front. That doesn't hurt a bit, does it? Do you know how to integrate cosine?
Sine.
Good job. Sometimes people get that backwards. Sine of u, and don't forget plus c. And what do I put back in here?
3x.
Perfect. Let me ask you one more question. What would happen if I took the derivative of this
you should get cosine. You should get your original answer.
Exactly. That's how this all works, isn't it? That's fundamental theorem of calculus. That's how it works. If I took the derivative, I get back to here. So I could actually check it if I had time. Now, I may
Okay.
not have time on a test that's, got a limited amount of minutes, right?
No.
All right, listen, thanks. I hope you guys are all coming to the prep session Saturday
Okay.
the 25th.
Okay.
Miss
We'll
May will be there and all the other teachers. We'll look forward to seeing you guys.
Okay. Thank you.
Bye-bye. Martha, who's our next caller?
John from Skyline.
Hey, John.
How you doing?
I'm fine. Who's your... Miss Lipsy, all right. How's Miss Lipsy doing?
She doing good.
Good. All right, let's find a good problem. How do you like position, velocity, acceleration?
I guess I could do it.
You guess? Well, that's good to hear. Okay, here we go. Are you ready?
Alright.
This is S of t, and that is your position function. T cubed minus 3t plus 3. And I want you to find the velocity function. That's all I'll ask you to do. Can
That's
you find
pretty heavy.
velocity? Tell me what to do.
Alright, you get the derivative, which is going to be 3t to...
That's right. I like to tell them I'm going to do that. Sometimes you never know. That might be a point. Okay, go for it.
You get 3t to 3t squared minus 3 for the velocity.
Is that it? 3t squared minus 3?
Yes.
All right, let me ask you another question. Where is the particle standing still?
Where's the particle standing still?
Uh-huh.
At 0?
When the velocity is 0, right?
Yeah.
All right. What time makes velocity 0?
Let's see. 3.
Factor out of 3?
Yeah.
All right. T squared minus 1. And what do you get?
Yeah.
Factor that one for me.
T plus 1.
T plus 1.
Yeah.
Good.
T minus 1.
T minus 1. Now, I didn't put a limit on t, so we've got two answers here, so we can keep them. The particle is standing still when the time is what?
Plus or minus 1.
Yeah, -1, +1. Now, if I'd said greater than or equal to 0, then you wouldn't have counted the negative, would you? But I didn't say that, so I guess you can count it.
Alright.
Standing still. Excellent. Good job. Listen, thank you for calling in. You guys know that. Round of applause. We're forgetting the bells and hearing. Round of applause. Martha, who's the next caller?
Our next caller is a Dante from
Lincoln.
Hi.
Lincoln.
Hello?
Hi, who is this? Lincoln, thank you, Dante, for calling in. How's Miss Etheridge?
Good.
Good. You got any refreshments?
Later.
Got what?
Later.
Okay, all right. Let's see what I got here for you. Let me find a good problem for you.
A good easy problem. Yeah.
A good easy problem.
Yeah.
A good easy problem. I don't have any of those. I'm sorry. I'm all out of easy
How about
problems.
some limits?
Huh?
How about some limits?
How about this one? I couldn't find my limit fast enough. If the function is this, okay? And that's my little smudge mark, so ignore it. F of x is x plus 1 over x minus 2. Could you tell me, just the first one, where the function is increasing and decreasing? Do you know how to do that?
Take
Say it again?
the derivative.
Yeah, that's right. Thank you. Sometimes I have trouble hearing.
That's right.
Here we go. I'm better now. Tell me how to take the derivative of this.
You
Tell
use
me your rule for this. What's your rule?
The quotient rule.
Yeah, tell me what you say or write.
Low D high.
Low
D high.
D high
Minus.
minus
High.
high
D low.
derivative of low
All over. Low square.
low squared. All right, good, because different people call it different things, so I like to know your rule. All right, the low one and the derivative of the high. Okay, tell me what to write.
Okay. Bracket. X minus 2. And another bracket. 1.
That's right,
problemo.
and I like going ahead and writing it, because that way you know you've taken care of it. Take
All
away
And you need a big bracket.
big bracket.
Alright. Then parentheses. X plus 1.
X plus 1.
Then alright. 1.
That's right. There's that big bracket. That way you like it.
Yes.
All right, and then what do you do on the bottom?
Low square.
Low squared. All right, can we clean up the top a little bit?
Yeah. You're gonna have x minus 2
X minus 2.
minus, well, okay.
You're fine. You're doing fine.
X
Minus x?
Minus 1.
Minus 1. That is beautiful. X
Yeah,
minus 2
baby.
quantity squared. And what does that clean up to on the top?
Negative 3
Negative 3 on the top.
over x minus
X
2
minus 2 squared. Now, that means the derivative is never 0, is it?
Yes, because the top is a constant.
That's right. There's something going on. What's going on at this function? At 2, what's happening?
It has a vertical asymptote.
That's right. So when we check on the sign, we need to consider that negative 2. It's a vertical asymptote, and that's where things can change, right?
Yes.
This is your derivative. Let me label it so you'll be able to tell. And I want you to check on both sides to see what this function is doing, okay?
All right.
If I plug in, what do you want to plug in on this side? I'm sorry, this is supposed to be 2, isn't it?
Yes.
Pardon me, I put a negative 2.
Alright.
All right, you want to plug in on this side first?
0.
0, I like 0. You get negative over...
Check, please.
Positive.
Positive, you get negative. Function's going down. Right? Now, greater than 2, what do you like?
4.
I like 4. You get negative over...
Positive.
Which is?
A negative.
Function's going down. This is one of those rational things that goes whoosh, whoosh, right?
Yes.
But you don't want to say it's going down everywhere, do you? Because that asymptote, it's going down over here. It's going down over here. So you're going to say the function is decreasing, and you're going to name both intervals, not one big interval, right? So tell me what to write.
Infinity
Negative infinity
to 2.
to 2, comma,
2
to
to positive
infinity.
infinity.
And I like to just put a comma, because you know, and in
To infinity and
Can
beyond.
I explain why?
You bet. Explain
All right.
why.
It is decreasing because f prime of x is negative.
That's exactly right. F prime of x
Correct, boy
is
wonder.
negative on both of these intervals. And that is a great explanation. That's the calculus explanation, isn't it?
Yeah, that's worth like 3 points.
Your teacher is doing a good job. You say that. That is a great job. Hey, bells. Double bells. Listen, thank you for calling in. You did a wonderful job on that problem. You guys call back.
All right.
Bye-bye. Martha, who's our next caller?
Our next caller is Fernando from Sunset.
Fernando. Ah, what picture number are you? Y'all are really carried away over there, aren't you? Here we go. Is it Fernando number 11? Is that you?
Yes.
Excellent. That's a good picture. All those good-looking students. All the calculus students are good-looking, aren't they? You think?
Yes.
Yeah, me too.
Oh,
All right.
wow, you look pretty cool.
For you.
Yeah, baby.
Oh, do you like logarithms? It's okay to say yes.
Oh, yes.
Can you step back from the TV just a little bit? We're getting some feedback. Okay, good. That'll be good. Thank you. That helps. All right. I've got g of x is natural log of the square root of x cubed plus 2. And I want the derivative. What would you like to do first?
Yeah, right.
I love that. Rewrite. Tell me what to write.
X cubed plus 2.
Say it again.
X cubed plus 2.
And what do you put? What do you do about that square root?
It'll be 1/2.
It'll be 1/2 out front. That's your logarithm rule. This is, in my opinion, why you studied those rules years ago, right? So you could use them today on this problem. And now, that's not the derivative, really. This is the derivative. What is the derivative? Go ahead, please.
3x squared
3x squared on top is perfect. What's on the bottom?
over x cubed plus 2.
That's right, x cubed plus 2. I'll put my parentheses. You know, we could rewrite it like this, 3x squared over 2 times this. That looks a little prettier, but I wouldn't think you need to do a whole lot more, do you? I love the way you did the rewrite. That's exactly, you do not want to take the derivative of this, do you? Way too much work. Good job. Listen, thank you for calling in. You did a great job. Round of applause. Martha, who's our next caller?
Ben from Brian Adams.
Hey, Brian Adams.
Bueno.
Hey, is it Ben?
Yes.
I'm glad to hear from you. How are you guys doing?
We're alright.
Have you taken a 6 weeks test?
Yeah, that was today.
Did you do well on it?
I probably failed miserably.
Oh no! Well, we better practice so you'll do better
I need
next
your
time.
help.
What's that?
I need your help.
Well, I'm sorry. I wish I'd been there.
Oh, righty
Probably
there.
wouldn't have let me, would she?
Nah.
No, she probably would have said he can do it himself.
Yeah.
All right.
Thanks for the offer, though.
Here we go. I got a good problem. I think you'll like this one.
Yeah. I love math.
I'm glad you love math. Tell Ms. Arthur that. Extra credit for people who love math. This is the kind of question I've seen on the test in years past. Will the following be an under
We haven't learned that yet.
Are you there?
Hello?
Hi.
We haven't learned that yet.
What? I'm sorry, I couldn't hear you.
We haven't done trapezoidal yet.
Oh, you haven't?
No, ma'am.
Well, let's just do right and left Riemann. That's okay. We'll leave off trapezoidal, okay? All right. Are you trying to fool me over there? Okay, from 1 to 3. All right, here's what I want you to think about. I want you to think about a left Riemann, just one big rectangle. If I drew a left Riemann, would I draw from here or from here?
From right there.
From which one? This one? Or this one?
Yes, the left.
The left. I draw from here.
Yes.
So that's a left Riemann. I'm just drawing one big one to see. So a left Riemann is too much or too little?
That'd be too much.
That'd be too much. So a left Riemann is an over approximation. All right, a right Riemann, I would draw from the right side.
Yeah.
Too much or too little?
I think that's too little.
That's too little.
Yeah.
You haven't done trapezoid yet?
No.
Well, let me draw in one for you. There's a trapezoid right there.
That's nice.
Too much or too little?
A little bit too much.
A little bit too much. That's exactly right. This was a question a few years back, and all you had to do was think about, I drew one big one because it's easier to see. If I'd drawn a bunch of little ones, I might not have been able to tell. But one big one, I could tell right away. Too little, too much, and then when you do trapezoid later, you'll know that's too much as well, okay?
All right.
Hey, thank you for calling in. You guys call back.
Yeah.
I'll see you soon.
All right, bye.
Martha, who's our next caller?
Stefan from Carter.
Hey, Stefan.
How you doing?
I'm fine. How are you doing?
I'm fine.
Let me find the problem. I want to show you something first and then let you help me with the problem, okay?
Okay.
All right. We've got some data here, and I want you to look, just looking at the data, if you assume it stays sort of the same all the way through the interval, I want to talk about the first derivative and the second derivative. And by that I mean the rate of change from here to here. How much did this change?
2.
From 10 to 12 was what?
2.
2. Very good. And how much did this change?
3.
And how much did this change?
4. 4.
From 4, yes, thank you. So, do you believe the function has a positive first derivative? Because all of these were pluses. Okay, I do too. It's a positive first derivative. And now the second derivative, from 2 to 3, what was the change of that?
1.
Plus 1, and from 3 to 4?
Plus
1. So this one has a positive first derivative. In other words, it's increasing at an increasing rate.
Yes.
Okay, now I want you to do this problem, okay? Which of the above could be a function with a positive first derivative and a negative second derivative? Or do you want to rule anything out? Look at all three and tell me, are they all positive first derivatives? In other words, are they increasing?
No.
Which one's not?
The last one.
The last one. This one is decreasing, so it's out of the running right now, isn't it? So forget it. All right, let's do what we just did. What's the rate of change here?
2.
And notice the x's are even, okay? What's the rate of change
3.
here? And here.
4.
And so the rate here is?
1.
And here is?
1.
That's a positive first derivative and a positive, oh, I don't think that's the winner. Let's try this one. Rate of change?
4. 3. 2.
Rate of change?
1.
Down 1.
Negative 1. And
Very
positive.
good. So which one's the winner? Positive
Okay,
first,
so the one in the middle.
the one in the middle wins. Positive first derivative, negative second
Second
derivative.
derivative.
That was a problem a few years back, one very similar. And if you know what to do, that's not bad, is it? But we haven't done a lot of that in recent years, so we're going to try to do a little more, aren't we? The next few tests will probably have some of that on it. Hey, thank you for calling in. You did a good job on that.
All right.
Just another way to look at first and second derivatives. Rates of change. Thanks for calling. Who's our next caller?
Francisco from Science and Engineering.
Hi, who's your teacher?
Miss Ada.
Miss Ada. All right. Are you on a cell phone?
Yeah.
Uh-oh, we're having
The school
trouble.
phone didn't want to go through.
That's what?
The school phone didn't want to go
The
through.
school phone wasn't working.
Yeah.
I'll see if the booth, if we can handle it, as long as it doesn't pierce my ear, okay? All right. Are you ready?
Yeah.
Got a little problem for you here. ln of x to the fourth over x dx. What are we going to do?
No problem.
Oh man.
We're losing him.
This is u. Can I help you a little bit?
Yeah.
And what's du?
1 over x.
That's right, dx. Oh, look, there's du waiting on us to notice.
Yeah.
They tried to trick us. So it's the integral of what? Now tell me what to write. U to the what?
U to the fourth.
With du sitting there, right?
Yeah.
Got a problem you can work now?
Yeah, I guess.
Bet. What is it? U to the,
U to the fifth.
yeah, over
5.
plus.
Plus 3.
That's right. And now one last thing we have to go back and fill in. I sometimes forget the power, so I usually write that first. What do I
Yeah.
fill in for u?
Ln of x.
That's right. The fact that the ln of x was raised to a power is a good choice for you, and guess what? There was the derivative. Once we got here, we could see it. It looks kind of scary here because it looks like a quotient, and we don't know
Yeah.
what to do with that. But it turned out to be u with du, and see, that's not too bad, is it? Not too bad. All you got to do is find a pattern you know how to work. Thank you for calling in, okay?
Thank you.
You guys call back. Round of applause. Martha, who's our next caller?
Our next caller is David from Molina.
Hey, David. Did you say hi to Martha?
Yes, I did.
Oh, good, good. Let me put your picture up.
the Jaguar.
Oh, here comes the Jaguar. David, I think that Jaguar is making noise. Do it one more time, Martha. Can you hear our Jaguar out there?
Yeah, I do.
You can hear it? Excellent. It seems like a baby, but it's got a growl to it, hasn't it?
Yeah, it does.
I got a problem here for you. Now my computer went nuts, so I lost the x there, but okay. This is the derivative. This line right here is a derivative. This is 2 and 5, if you can't see that. It's over 2 and 5.
Okay.
That's the derivative. Look how many times they tell you. Derivative, derivative, derivative. They tell you 3 times that it's the what?
The derivative.
Derivative. Then they tell you that something about the function at 0 and the function at 2. How do you get from derivative to function?
They integrated.
You integrate. So if they want to know about 0 to 2, can you tell me how to set this up?
You integrate
All right. From what to what?
from 0 to 2.
Yeah, that's what they're interested in, so let's do that. Now tell me, in theory, what do I get when I integrate h prime? I get h of 2 minus h of 0, right?
Yeah.
Good job. How do I integrate this function? What can I do? The integral is the area.
Yeah. It's the accumulation there. You can integrate.
I do. I can just find the area under the curve, right? This is a triangle,
Yeah.
right?
Yeah.
It's over 2 and up 5. Can you tell me the area of that triangle?
It's 1/2 base sometimes.
And 1/2 what times what?
The base, which is 2,
Uh-huh.
and the height, which is I believe 5.
That's correct. It is. It's hard to see sometimes, but you're exactly right. What's the answer to 1/2 2 times 5?
5.
5. Do we know h of 2?
No.
No, that's what we're looking for. Do we know h of 0?
Yes.
We can plug it in. Now what do?
You can take -7 to the side,
And what does that give me?
+7, which is 12.
Good job. That is a great problem, and you handled it beautifully. You knew to integrate the derivative. When you integrate the area under the curve, you know the fundamental theorem. You set it up beautifully. That question was hard for students a few years back, but it won't be hard for us, will it?
No, it won't.
No, you did a good job. Listen, thank you for calling in.
Thank you.
You guys call back.
Bye.
Bye-bye. Martha, who's our next caller?
Alvaro from Skyline.
Hey, Skylar.
Hi, Alvaro has to leave, so Jessica's gonna phone out.
Well, thank you, Jessica. Who's your teacher?
Miss Johnson.
Miss Johnson. Do we have your picture?
Yeah, but I'd rather not be shown.
Oh, okay. Well, that's your choice. I'm going to peek and look in a minute, though, okay?
Can you
All right. Let's see what we got here. Let me find you a really nice problem here. Oh, are you acting like you want an easy one?
Well, I'm just...
Nah, you don't want an easy one. You want a difficult one. Oh, this is a great problem. Are you ready? Oh, it's okay. You're going to love this problem. The secant of the natural log of x times the tan of the natural log of x over x times dx. What are you going to do?
Use substitution. No.
What are you going to do?
Wait,
Say it again. Do you know anything about secant something tan
Yeah.
something? Yeah. So what is this going to be? This is, what letter do we like?
I'm sorry, what?
What letter do we love for
U.
this? U. U is the don't let it scare you,
Natural
just
log.
start in. And what's du?
1 over x.
Oh, guess what?
dx.
There it is right there.
Yeah.
Yeah, it's right there. So you've got the integral of what?
Secant
Secant
u
u.
tan u.
I like that problem because it looked horrible and it's not so bad now, is it? What is the integral of secant u tan u?
Secant
That's
squared
right.
x.
It's just secant
Oh, you secant. I'm sorry.
of, that's okay, secant
Okay.
of u, and don't forget plus
Plus c.
c. And I always forget what u is, but that's why I wrote it down.
Natural log of x.
Natural log of x. Isn't that a great problem? This looks horrible, doesn't it?
Yeah.
But
it
when
really
you
does.
see this and you stop and think, wait a minute, let that be u. Oh, there's the derivative. Not so bad, right?
No.
Not so bad. It's all about finding the pattern. Man, you did a good job. That was a hard problem, and you just scored right through it.
Yeah.
Excellent. Thank you for calling in. You guys call back.
Okay.
Bye.
Bye.
Liza, who's our next caller?
Now we have James from Bryan Adams.
Hey, James.
What's up?
Are you there?
Yeah.
I lost my earpiece just a minute. Okay. All right, let's see what we got going on here. You've done E's and that sort of thing, right?
Yeah.
Oh, I know. Here we go. What I've got for you here is a problem. G of x is 5x over e to the 2x, and I would like a derivative. What do you tell me what your rule is for derivatives of this kind? What do y'all say, Bryan Adams?
Is it a quotient?
Quotient rule. That's right. What do you call it? What do you say for quotient rule?
Is it whose phone is that?
Pardon me?
What is it? Is it B times
B.
the derivative of A? B.
B. Oh, B
Yes.
times derivative of a
Yes. Minus
minus
A times the derivative of B.
over.
B squared.
I get it. BA.
B squared.
B squared.
Yes. Yes.
I liked your letters. I got carried away. Okay, good. So that's the bottom and the top, right?
Yep.
A and B. All right, go for it. Tell me what to write.
Let's see. So B is E to the 2x
E to the 2x.
times the derivative of A, which is 5,
Excellent.
minus A, which is 5x, times the derivative of B, which is E to the 2x times 2,
Great. Over.
all over E to the 2x squared.
Excellent. Let's see if we can clean this up just a little bit. How would you change e to the 2x squared? When you raise power to a power, what do you do?
Multiply.
And tell me what to write. Good.
E to the 4x.
That's excellent. All right. Could I take a 5 out?
Yeah.
Yes. Could I take an e to the 2x out?
Yes.
Yes. And what would that leave inside?
Let's see. That would be 1
1
minus x.
and
2x.
times the 2, right?
Yeah.
I think that is right. I think that looks good. Let me ask you one more question.
All right.
Is e to the 2x ever negative?
No.
No. What about e to the 4x?
No.
No. They're positive, right?
Yeah.
And so this would be the only piece of the puzzle that could be positive or negative. True?
Yeah.
We'll talk about that some more later.
All right.
Thank you. You did a great job with that. You know your e's. It's important to know what e is, right?
Yep.
Thanks for calling in. You're call back.
Bye.
Bye.
Our next caller is Jose from Molina.
All right, let's show your picture.
Number 22.
Number 22. All right, just get your picture all ready. Here we go. There we go.
Wow, you look pretty cool.
Yeah, baby.
You look like you love calculus. Is that true? Are you there?
Yeah.
All right, here we go. I got a problem for you. Let me put something. I've got 2 on the page. I want to cover one of them. All right, are you ready? Okay. F of x is the natural log. Can you step back a little bit from the TV where you can still see it? Are you there? f of x? Oh, I'm sorry, we lost you, so we'll go to the next one. Who's our next caller, Mike?
Clifton from Lincoln.
Clifton from Lincoln. Hey, Clifton, are you there?
Hi, how are you?
Clifton? Okay, good. Are you ready?
Yes, ma'am.
All right, we got a problem for you here. I got one already. F of x is the natural log of all this stuff, and I want the derivative at 0. So what do you do first?
Well, since you're taking the derivative of a natural log, it's going to be du.
All right, say it again.
It's going to be the derivative of
Right.
the function over the function.
Okay, derivative of the function over the function. I like that. So tell me what to write. Y'all put the function for you. How's that? I always like to do the easy part, and then let you do the hard part. What do you think? Does that work?
Yeah. That's
Okay, good.
So at the top, you're going to have 3,
3.
and your 5 is going to go away because it's a constant.
That's right.
So you're going to have a negative 2x e.
Say it again.
Oh, negative 2 e.
E to the negative 2x with a chain out. Are you there?
Huh?
I'm sorry, I was having trouble hearing you for a minute. Sometimes we get a little static. It's e to the negative 2x with a chain out,
Yes, ma'am.
negative 2, right?
Yes, ma'am.
You did a great job. You knew exactly what to write. I like to think du over u. Is that what you think, or you think another way?
No, I was thinking du over u.
Yeah, I like to think that, and then I like to write the u first, because then I get that out of the way. That's easy, right?
Yes,
And then the derivative. And e to the negative 2x, whoops, got carried away there. It's e to the negative 2x with the chain out of the derivative of of this portion, right?
Yes, ma'am.
You did a great job. Thank you guys for calling in. You guys call back.
All right.
Martha, who's our next caller? Uh-oh, have we got a caller?
No.
Hold on.
Hi.
Dominique
Hello.
from Skyline.
Dominique from Scon. Hey, who's your teacher?
Miss Johnson.
Miss Johnson. All right. How's Miss Johnson today?
She's fine.
She's doing well?
Doing well.
All right. Let me get you a really good problem here, okay? Do you like to solve initial value problems?
Sure.
Okay. You know, this is dy dx, and we want to find y, and we have a special value to plug in. So how do you get from the derivative to the function?
Integrate.
That's right. So let me set up dy equals 3x minus 4 cubed dx for you. Now, tell me what to write.
The integral of dy
Okay.
is equal to the integral of you already have everything
All that
down.
other stuff. Yeah, I wrote
Okay.
that for you so you wouldn't have to worry about it. Okay, now, what do we do?
The integral of dy is y. Is just y.
Yeah, that's our favorite part, isn't it?
Inverse function. Yeah.
There you go. All right, now, what are we going to do about this one? How do you handle that?
U substitution.
Excellent. I'll go over here to the side. What does u equal?
3x minus 4.
And what does that make du?
That would be 3.
3 dx. Do you have 3? How do you fix that?
1 multiplied by 1/3.
That's right. du over 3 is your dx. All right, now tell me what to write for the substitution. Integral of?
1/3 integral.
Oh, I forgot that. Yeah, you said it and I didn't write it. Thank you.
Okay.
1/3 integral.
U to the third du.
All right, and now we're ready to integrate, aren't we? This is going well, isn't it?
Yes, it is.
All right, 1/3.
Okay, u to the fourth divided by 4.
And I'll go ahead and put,
Plus C.
I guess I better put plus C. Okay, well, keep going.
Okay, u to the fourth over 12. U is 3x minus 4.
Okay. I like to set it up so I don't forget the power. Okay, so far so good. We have a nice function here, and they gave us an ordered pair. They said 1 and minus 1. And so now how do you finish getting the final answer?
Substitute.
Okay, tell me what to write.
-1
Good job.
equals 3. 3 times 1 minus 4. All to the fourth power over 12
Okay,
plus C.
excellent. I'm going to have to get some more paper here. Keep going.
3 minus 4 is -1. raised to the 4th power.
Okay, let me write that. That's what you said. Did I get it right?
Yes, ma'am.
Okay, keep going.
So you'll have 1 over 12 plus C.
So what does that give me for C equals?
Subtract 1/12 from -1.
And what does that give me? You could say it any number of
Negative.
ways. Go ahead.
-13/12.
That's fine with me. I like -13/12. She could have said -1 and 1/12 if you wanted to.
Okay.
Now let's go plug that back in up here, right?
Yes.
So you'd plug in y equals all of this plus or minus
Negative
13.
13/12.
Very good. And you'd want to do that. I may run out of room, but you'd want to do that on the test to get full credit, wouldn't you?
Yes, ma'am.
Hey, you did a beautiful job. That's a nice little problem. Double bells. Martha, who have we got?
We have Veronica from Sunset.
Got a big crowd over there at Sunset, huh?
Hello?
Hi, Veronica. How are you?
Fine, and you?
I'm fine, thank you. Let me show your picture. Excellent. You look great. Is calculus your favorite class?
Of course.
Of course. All right, let me pull back a little. You see these 3 graphs when they come up?
Yeah, baby.
Here we go. I'm hoping you can tell me which one's F and which one's the derivative F and which one's the second derivative. Martha, Martha, is that our last caller?
Yes.
All right. You're our last caller. Here we go. Do you know which one is F, F prime, and F double prime?
Huh?
Can you tell which one is F and which one is the derivative and
Yeah.
which one is the second derivative?
Yeah.
Okay, help me. Which one do you think is F?
The one that's decreasing to your right, the top right.
1, 2, 3. This one?
Yeah.
You think this is F. All right, let's try it. Then which one is the derivative?
The one at the bottom.
All right, let's see if that works. The derivative would be all negative. I think the derivative's got to be all negative. So which one's all negative?
The bottom one's F.
Oh, okay, let's try that. You think this is F. All right, F is going up and then going down. So what's F prime?
F prime is the other one, the one at the top.
You did. That's great. That's hard to tell at first. Sometimes it's hard to tell. You did a perfect job. So which one's F double?
The last one.
Excellent. And I look at things like the slope is 0, and that has a 0 slope, therefore the derivative. You did a great job. Listen, thank you guys for calling in. I want to thank you all for calling today. I want to thank my student host, Martha. She did a great job. We have 2 gift certificates for lucky callers. Martha has set up the calculator, and now we're going to see who the lucky callers are. I'd like to see it on the air. So we had 20, how many callers? 23 callers. That's pretty good. All right, Martha's got it set up. Let me zoom in so you can see what the Gaming Commission know we're telling the whole truth. All right, the first lucky winner is number 22 and number 12. Martha, who are those lucky winners?
Number 22 is Dominique from Skyline.
Dominique from Skyline.
And number 12 is Avante from Lincoln.
Avante from Lincoln. I'll get those cards out to your teachers. I hope you'll tune in next week for Calculus Live. Keep on studying. Martha and I are wishing you 5s on the exam on May the 3rd. Work hard so that you can celebrate when those results come in.
Hasta la vista, baby.